So let me start with the Naive algorithm. Naive quickly builds mining models, and you can use these mining models for classification and prediction. Because of its speed, it is very useful as a beginning of a data mining process or beginning of creating data mining models. So also this makes these Naive models a good option for exploring the data. The logic of the algorithm is the following. It calculates probabilities for each possible state of the input attribute given each state of the predictable attribute. Basically, it calculates frequencies distribution of input attributes in the classes of the predictable attribute. And these probabilities can be used later to predict an outcome of the predicted attribute based on the known input attributes on new cases. All input attributes are treated as mutually independent. This is where the naive part of the name comes from. The algorithm uses one input attribute at a time. So let me explain this graphically. Imagine that I am buying a second-hand car. Based on the experience and information from newspaper, I know that only 70% of second-hand cars are okay and 30% of them are faulty. My friend is a mechanic, so I can take him for a quick drive. And based on this quick drive, he can make an educated guess. He will declare a car as faulty or okay. He's not always correct. He will correctly declare 90% of the faulty cars as being faulty and incorrectly declare 10% of them as being okay. And he will declare 80% of the good cars as actually being okay and incorrectly declare 20% of these cars as being faulty. So altogether, my friend will judge 41% of cars as being faulty. I get this number by calculating 0.9 multiplied by 0.3, which is 0.27, for the correctly declared faulty cars as being faulty, and summing with 0.2 multiplied by 0.7 for the okay cars which were incorrectly declared as being faulty. Similarly, I can calculate the percentage of the cars that my friend judged to be okay. This is 59%.